Hello, I am Miss Adams. Today I'm going to start an algebra review with you to make sure you're prepared for Algebra 2. But before we jump into the math, I'd like to start with a riddle. What type of clothing does a house wear? A dress. Address, you get it? Of course. Anyway, let's start with the order of operations. The order of operations is vital to your success in Algebra 2, so I just want to make sure you remember it. Some people say PEMDAS, some people say please excuse my dear Aunt Sally, and that's just a way to help you remember the order. We start with parentheses, then we go to exponents, for example, if something is squared or cubed, and then multiplication in order from left to right. So that means sometimes division will go before multiplication. And lastly, we have addition and subtraction in order from left to right. As you watch my videos, it's a good idea to write the example and pause the video. So that way you have a chance to work the examples out and then unpause and see if you got them correct. That's active note-taking. Okay, so we're going to look at please excuse my dear Aunt Sally, and I'm going to do parentheses first. So I'm going to rewrite everything and only do what's in the parentheses. Now, the next thing I want to do is I have division here and I have multiplication. So I'm going to do the division and multiplication in order from left to right. So that means I'm going to do the division first, right? 16 divided by 8 is 2, and then multiply by 2, and my answer is 4. Common mistake would be to do the parentheses and then say 16 divided by 8 times 2, like that. That would be the common mistake. Please don't do that. 4 is the correct answer. Let's recall how to solve equations. And I'm sure your algebra teachers did a great job. I just want to refresh your memory. So I'm going to distribute the 3 to both terms here. And now I'm going to put all the x's on one side. And I personally like to move all my x's to the left. However, it really doesn't matter. Let's get rid of this 12 by doing the opposite of addition, which is subtraction. So that's going to make that go away. And notice this was positive 5, so I subtracted. That was opposite. So now that goes away. That's how we undo addition and subtraction. We call those inverse operations. We'll talk about that later this year. So now, remember, whatever's multiplied by the x, we divide that on both sides. And recall that a negative over a negative becomes positive. You're going to learn in this class, it's better to just keep that rational number. Rational. Okay? Some of you may like to call that an improper fraction. You just make sure it's reduced and you leave it alone. Later, we're going to talk about why rational numbers are really useful in math. And I'll give you a quick example. Some people would probably want to change that to 6.5 or 6.5. But what if I told you to multiply this number by 4? Well, in its rational form, that would be very easy. And we could see 13 times 2 is 26. But if you tried to multiply this by 4, you'd have to do a little more thinking. Or even this, it'd take you a little longer. So rational numbers are very easy to work with. Like I said, and rational means in the form A over B. Okay, rational, root word is ratio. Let's proceed with another equation. So I want to, and actually, let me address this. Let's write the order of operations, but notice how I'm writing them. Please excuse my dear Aunt Sally. As you solve an equation, you do the order of operations backwards. So you start with addition or subtraction, and that's what goes first. Okay? And then you go multiplication or division. That's how we get the x by itself. And let's be clear, we are solving for x. That simply means get x by itself. That's what it means to solve for a variable, is to just get it alone. What we're doing today may sound very simple, but pivotal as we move into Algebra 2, pre-calculus, calculus. These things are very important because you're going to see more complex equations and more complicated functions. And I want you to just remember to do the same thing always. So now multiplication and division undo each other. In order to get rid of that 3, I'm going to do the opposite of division and multiply. And I get negative 45. Now let's look at a technique for clearing decimals. We could work this equation in the same way where we simply add 3 to both sides and combine the decimals with the x's. But working with the decimals, I'm not in the mood, okay? So I'm going to show you an easier way. Again, you might want to pause the video and give it a try yourself. But here's the technique that I'd like you to do for clearing decimals. See which decimal has the most places. This one has 2, this one has 1, and this one has 2. So what we're really doing is multiplying by 100. That moves the decimal twice. So wherever the decimal is, we're going to move it twice. Okay? Let me undo that. I don't want anyone confused. And so every decimal, it's here, so we're going to move it 2 places, and now it's here. This decimal starts here. I'm going to move it 2 places, and now the new decimal's there. 2 places, that's multiplying by 100. And 2 places, now the decimal's here. Now, watch how lovely this equation becomes. This becomes 15x. Now, when you move that decimal, we need some placeholders. This becomes 300, 40, and 25. Now, super easy. I'm going to move my x's to the left. However, if your preference is to move to the right, that's absolutely fine with me. You'll get the same answer. Again, notice those opposite signs. I always have students that love doing work in their head. The head can be dangerous. That's where a lot of simple mistakes occur. The more steps you write out, because you're seeing it, it helps you not make those silly mistakes. Okay, so I urge you to definitely take your time and write things out. It's better to get things correct than to be finished first. Also, I always have students that, I want to do it the old way. I want to do it the way my middle school teacher taught me or whatever. I say, know that way and perhaps learn a new way makes you a stronger student. I'm trying to create math warriors. Let's go. For this, to clear fractions, let's write that down. We're going to solve by clearing fractions. This is a technique that has really helped me with complex problems. Okay, for this problem, not that necessary. Now, don't write this down, but I'm going to show you how most of my students would start this. They would subtract 3 from both sides. That would go away. And we don't have common denominators. Have to get common denominators, right? And so I'm not sure how you learn to do that. But you'd have negative 6 over 2. And that'd be negative 7 over 2 for when you combine those. And then you would get the x's together. And, we need common denominators again. We need that to be a 12. And notice that gets into more work than we really want to do. So I'm going to show you a way to get rid of the fractions where you don't have to worry about doing all that. Okay? What I start off by doing is multiply by the common denominator. Don't get the common denominator, but multiply by the common denominator. Right now, I'm trying to annotate your notes. So you always want to put comments so that when you get home and look at your notes, you don't say, oh my gosh, where did that come from? You already know because you've made that comment. So the common denominator, we have a denominator of 3, 1, 4, and 2. You have to look at each and every term. Terms are separated by addition or subtraction. So 12 would be a good common denominator. So notice I'm multiplying every term by 12. Every term. And I kind of like to put it in the numerator in front of the fraction. It just works good for me. And now, look, 3 goes into 12 4 times. 4 goes into 12 3 times. And 2 goes into 12 6 times. I didn't have to do anything with that 1. But watch how lovely this equation becomes. 8x plus 36 equals 3x minus 6. All I did is look at everything that's left and multiply together if needed. And now this becomes a really simple equation. I can subtract 3x from both sides. The opposite of 36, I'm going to subtract 36. Now I have 5x equals negative 42. And now I'm going to divide both sides by 5. And x equals negative 42 over 5. Can that be reduced? Nope. No common terms. All done. Remember, We don't want mixed numbers and we don't want decimals.